Hey everyone, we're going to jump right in today with a question that honestly sounds like it's straight out of science fiction. How do you teach a machine to see? This isn't just about cameras and code, it's about giving computers a real understanding of our visual world. And we're going to break down exactly how it all works.
Think about it. You probably do this a dozen times a day without even noticing. You glance at your phone and poof, it unlocks. It knows it's you. Out of billions of people, it recognizes your face in a split second. How is that even possible?
Well, the answer isn't magic, although it definitely feels like it sometimes. It's a field of artificial intelligence called computer vision, and it's the secret sauce behind so many things we now just take for granted.
So, what is computer vision really? What's the big idea? Let's start at the beginning and trace it back to its, well, surprisingly ambitious roots.
So here's the official textbook definition. But what it really means is that at its heart, computer vision has one massive goal: give computers the ability to understand the world through images and videos. Essentially, to automate the incredible power that you and I have with our own eyes. It's not just about seeing a picture, it's about getting what's actually in it.
And this is really the fundamental difference. When we see a picture of a cat, we see a living, breathing thing. We get the context, the fur, the behavior. A computer, on the other hand, just sees a big grid of numbers, pixels. The entire goal of computer vision is to teach that machine how to find the patterns in that grid that scream cat. It's seeing data, not the world.
You know, getting here has been a wild ride. It's almost funny now, but back in the 60s, some of the smartest people in AI genuinely thought they could solve computer vision in a single summer project. Yeah, turns out it was one of the most complex challenges in all of science. For decades, progress was slow and steady. But then, the deep learning revolution hit, and suddenly, everything just accelerated into hyperdrive.
So what did deep learning actually unlock? How does a modern system go from that meaningless grid of pixels we talked about to making an intelligent decision? Let's pop the hood and take a look.
It's pretty much a four-stage pipeline. First, you've got acquisition, where a camera turns light into raw data. Then comes pre-processing, which is kind of like sharpening a blurry photo to clean it up. Stage 3 is where the real magic starts, extraction. The system hunts for key features, the edge of a jawline, the corner of an eye. And finally, the decision phase. It puts all those features together and asks, do these specific features match the phone's owner? Check. Access granted.
And that same basic process lets computers do way more than just recognize faces. It can be used for motion analysis, tracking a single car through chaotic traffic footage. It can do scene reconstruction, building a 3D model of a room from just a few 2D photos. It can even perform image restoration, intelligently filling in the blanks on a damaged old photograph. It's pretty amazing.
Okay, so these aren't just theoretical tasks happening in some university lab. This technology is already deeply woven into our lives and our industries, often in ways we don't even notice. Think about it. Self-driving cars need to see pedestrians and stop signs. Doctors are using it to spot tumors in medical scans, sometimes far earlier than the human eye can. It's in factories checking for microscopic defects, it's on drones monitoring crop health, and it's the core tech that makes augmented reality possible. It is truly everywhere. And if you need any more proof of its impact, just follow the money. In 2024 alone, the market for computer vision in industry is over $5 billion. In medicine, it's over $2.5 billion. This isn't some niche academic field anymore. This is a massive economic engine.
And let's just stick with the medical side for a moment. Computer vision isn't just about spotting problems. It's also a powerful tool for discovery. By analyzing thousands of brain scans, it can uncover subtle patterns related to diseases that a human might totally miss, accelerating research and helping us understand the human body in a whole new way.
So, with all this power and all this economic force behind it, where's this technology actually headed? What's the ultimate goal? And what are the big questions it forces us to confront?
This quote really just captures the whole thing perfectly. The end goal isn't just for a computer to label an image car. It's to understand that the car is moving quickly towards a pedestrian and then, and this is the most important part, to take the appropriate action, like hitting the brakes. It's about turning sight into intelligent action.
Which leaves us with a final, and honestly, a crucial question. As we build these machines that can see and interpret our world with superhuman ability, we have a huge responsibility to decide what they look for. What problems do we want them to solve? And maybe, more importantly, what do we want them to ignore? The future of sight isn't just about the technology, it's truly about the choices that we all make.